Hi everyone. Today I'd like to go over this FE statics problem with you guys. And while it may look daunting at first, the truth is that this problem can be solved in 2 to 3 steps. So let me go through that solution with you guys today. I'm going to read through the problem and take a few notes. So let's go ahead and do that. A box with constant density has a weight equal to 800 newtons. Let's note down that weight. The weight is equal to 800 newtons. It says constant density, so that means the mass center is directly in the center of this box, and I kind of marked it there. It's suspended via 3 cables, and the top surface is perfectly level. The common suspension point is 1.7 meters above the mass center of the box. What that's telling me is that points E in the mass center are vertically aligned, as well as the distance between them is 1.7 meters. Our task right now is to determine the option which is most nearly the tension in cable AE. Firstly, let's start off by drawing a free body diagram. We're going to cut some of these cables to expose the tensile force in each of the cables. Let's go ahead and mark that force in AE in red, and we'll mark the other forces in black because they're not as important to us. Lastly, there's a weight which is placed at the mass center, whose magnitude is 800 newtons. And again, we're looking for that tensile force in cable AE. A lot of the times when you have multiple forces on a free body diagram and you're just looking for one in particular, what you're going to do is take a moment, and you want to take that moment strategically. A strategic place to take the moment here would be if we placed our axis at point B, with this being the x, this being the y, and by the cross product, the z-axis must be pointing up. Why would I want to place my coordinate system there? It's because if I took a moment about the y-axis, I know that the force at B won't produce a moment, the force at C won't produce a moment, only the force at A will produce a moment, and not even the entire force will produce a moment, just certain components of it. We have at A an X component, we have a Y component, and then we also have this Z component. The X component of the force is intersecting the Y-axis. It's not going to produce any moment. The Y component is not going to produce any moment because it's parallel to the Y-axis. Only that Z component will be able to produce a moment. Let's write down the equation of the moment. The sum of the moments about the Y-axis must be equal to 0. The 800 Newton weight is going to be producing a moment about the Y-axis. It tends to cause a rotation of the Y-axis going in this kind of orientation. That means that 800 multiplied by the moment arm, which is half the width of the box right here, or 0.3 meters. We know due to that rotation direction, if we kind of curl our fingers in the direction of the rotation that weight is going to be producing, we have a moment which is pointing to the left on the y-axis. It's pointing in the negative orientation of the y-axis. So that means this is negative. Conversely, that z, because it's in the opposite direction, is going to produce the opposite rotation. So we're going to put a plus. Fz multiplied by its moment arm is going to be the entire width of that box, the entire 0.6. And this equation helps us to conclude that the force Fz is equal to 400 newtons. Now we know that Fz, and another important piece of information that we know is that the tension force must be along that line AE. An easy way to describe the direction of that line AE is using the position vector. That position vector AE can be described if we travel from point A to point E. So let's go ahead and draw out that path. We can travel along the X direction, 0.3 meters, along the Y direction, 0.4 meters, and along the Z direction to point E, that would be 1.7 minus half of this width. We kind of dimension this. 1.7 minus half of this distance, which is 0.5, would be 1.2 meters. We traveled 0.3 meters in the X, 0.4 meters in the Y, and 1.2 meters in the Z. We know that all we have to do in order to get that force AE is scale up that position vector by some scaling factor. That position vector is 0.3, 0.4, and 1.2. The scaling that we have to perform is one that would allow this Z component to be equal to 400 newtons. If we multiply by the ratio of 400 divided by 1.2, we know that we'll be able to scale it up such that the Z component of that force will be equal to 400 newtons. We're not interested in finding the X, Y, and Z component of that force. All we're interested in is the magnitude, the tension in that cable. FAE is equal to the square root of the sum of the squares of those components. The 400 over 1.2 ratio, that's a common term which can be taken out. And we still have that 3, 4, and 12 to find the magnitude of. The 3 and 4, it's called a Pythagorean triple, right? 3, 4, 5 triangle. So this is technically 0.5 and 1.2 is what we're finding the magnitude of. That's another Pythagorean triple, 5, 12, 13. So essentially this can be reduced to 1.3 squared. So this entire quantity is 400 times 1.3 over 1.2. That means that this is equal to approximately 400.33 newtons. If you didn't like the 3, 4, 5 right triangle, the 5, 12, 13 Pythagorean triple, you don't need to do it like that. You can simply find the magnitude. Let's go ahead and input that force. Input our solution here. Shows as 433, and we got the correct answer. If you're interested in beta testing this app, please, I have a sign up in the description below. You can leave your email there and I can reach out to you as soon as this is complete. Another thing I'd like to talk about here is this could easily be turned into a very nice conceptual problem. Let's say that we went through that description, this entire question description. Let's say no numbers were used, but we knew that the mass center and point E were aligned. They could ask you, what is the tension at B? If we took a moment about the line AC, we know that the force A is not going to produce any moment. The force C isn't going to produce any moment. The weight intersects that line AC. So that means that the moment produced by B must be equal to 0. That means that the tension in cable B is actually equal to 0. So that's something that wouldn't even require any work, just a good conceptual understanding. So that could be a good question as well. I hope you guys enjoyed this video. Please like and subscribe. I'll be making more videos like this. Keep learning and keep working hard. Goodbye.